Let's talk about radicals. First one we're going to talk about is the square root. Most people are familiar with the square root. If you're not, we're going to do a brief review. That symbol, the check mark symbol, is called the radical sign. So when you see the square root of a, what that's asking for is the non-negative or the principal square root of a. That means our answers are going to be the positive values only. Now there's a minus sign in front or a minus sign underneath that will change things. So here's what's going on. When you're asked to find the square root of 25, you're asked to find what number squared is 25, and that number is 5. Now if you don't know about your calculator, in the TI-83, by the x squared key, there's a check mark or radical sign, square root key. So if I type in square root of 25, hit enter, we get the answer. Now negative square root of 81, since the negative's on the outside, the negative is going to stay. The square root of 81 is 9. Once again, you can type it in as you see it. And negative 9 is the answer. Square root of 0, what number squared gives you 0? Well, 0 does. 0 squared is 0. Or if you check it, square root of 0 is 0. Now we come to the square root of negative 9. What number squared is a negative 9? If you type that in, you're going to get a non-real answer. So, let's talk about this one for a second. If we're on the real number system, we'll say there's no real number. But if we're dealing with imaginary numbers or complex numbers, there is a number. It will simplify. The square root of 9 is 3, and the minus sign underneath the square root or under any even radical, any even root, comes out as an I. So hopefully that isn't the first time you've seen that. It's based on a definition that I equals the square root of negative 1. And the only other thing you have to worry about is I squared equals 1. Now there's an I key in your calculator, so if you ever need to use that, it's right there by the decimal key. So be aware, in college algebra, you're probably going to see that as an I for the most part. Now let's do the square root of 49 over the square root of 121. Square root of 49 is 7, and square root of 121 is 11. You can also do that in a calculator. You can hit enter, you get a decimal, but you should know by now that you do have a fraction key under the math, and there you go. Let's see what else we have here. Now not every number is a perfect square. So for example, square root of 7 is an ugly decimal. So this means that we can approximate it with that decimal, 2.646. But more than likely we're going to leave it as square root of 7 in college algebra. Nth roots, there are other things besides the nth roots. There's cube roots, there's fourth roots, fifth roots, whatever you want to use or find. And the signs will make a difference, especially when you're dealing with the odd roots. So for example, the cube root of negative 64, we're thinking what number times itself 3 times, or what number cubed gives us negative 64. The actual answer is negative 4, because if you take negative 4 times negative 4 times negative 4, you get negative 64. But you can also do that in a calculator. If you hit the math key, you will actually see the cube root, number 4. Then negative 64, enter, negative 4. Now the fourth root of 81 is actually 3, because when you take 3 to the fourth, which is the same as 3 times 3 times 3 times 3, you will get 81. But if you look under the math key, you won't see a fourth root key, but you do see an x root. So here's how you use that. First thing you want to do is hit the 4, type in the 4, go to the math key, and then hit the 5. That 4 now takes the place of the x. So that's, the calculator sees it as the fourth root of, in this case, 81, which is 3. Now, the fifth root of negative 1, same thing. Hit 5, math. You can go down, hit enter, or just hit the 5. And then the negative 1, and you'll see the answer is negative 1. Once again, with the odd roots, you can't have a negative number underneath, because the negative times itself an odd number of times is still negative. It's the even ones you have to worry about. Now the last thing we want to talk about, and this will appear throughout college algebra. What we're going to do is simplify a radicals. What that means is we're going to rewrite, for example, number 40 in terms of pairs of factors that multiply together that give 40, but also one of them must be a perfect square number. Now, I'm going to do this by hand first, and then I'm going to show you how to use a calculator to help you out. And if you happen to see a number in front of the radical, and we will eventually have a number in front of the radical, that's going to mean that's multiplication. So the square root of 40, here's what we're going to do. There's all kinds of ways to do this, but one way to do is take the number 40 and think about what times what is 40. Well, 1 times 40 is 2 times 20, 3 won't divide, 4 times 10, 5 times 8, 6 won't go, 7 won't go, 8 will go, but we've already got the 8 in our list. So here's our 4 pairs of factors that give us 80. We multiply them together. So when you look at this pair is the only one that has a number that's a perfect square. The number 4 is. So the square root of 40 is the same as the square root of 4 times 10, which is the same as the square root of 4 times the square root of 10, which is the same as the square root of 4 is 2, and the square root of 10 remains underneath as it is, square root of 10. So the square root of 40 simplifies as 2 square root of 10. Now watch this on a calculator. You can actually type in this case, 40 divided by x. Remember, x is going to be 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So when we look at the table, you'll actually see the pairs of numbers that multiply together to give us 40. And we're only going to look at the nice positive numbers. So we have 1 and 40, 2 and 20. 3's got a decimal with it, so we don't want that one. 4 and 10, 5 and 8. 6 times the decimal, don't want that. 7 times the decimal. 8 times 5, which you already have it up here, is 5 times 8. So the table will actually give you the exact same listing that I have. It's just a little bit quicker. And something else you can do, you can go ahead and type in x squared, because a lot of people don't know what the squares are, the squared numbers, perfect squares. Well, over here is what they are, because you look at my y2, it's just every number squared. 0 squared, 1 squared, 2 squared, 4, 9, 16. I don't want to look at the graph. I want to look at these. So I'm looking for these numbers in my pairing. And so that's why I'm using 4 times 10, because 4 is the square of 2. So let's use our calculator to help us with the square root of 18. So all I need to do is change that 40 to an 18. Now watch this. I have 1 and 18. Don't want to use that because neither one of those are perfect squares. Well, 1 is, but we don't want to use 1s. We want to use the biggest perfect square factor. 2 and 9, 3 and 6. That's our only 3 pairs, and we're going to use 2 and 9 because 9 is in this list over here. Now I have to write it as square root of 9 times the square root of 2. Or square root of 9 times 2, if you want to put that step in. Or just leave it all out together, and I'll show you how you do that in just a second. And the square root of 9, if you look at 9 over here, is the square of 3. Because this is the x squared key. 3 squared is 9. And then the square root of 2 stays as it is. And that's your answer. Let's do one more. Square root of 80. Look at the table. I have 1 and 80, 2 and 40, 4 and 20. 4 is a perfect square number. But look, 5 and 16. 16 is also. And I think that's all we have. But we'll keep on looking. 8 and 10, but neither one of those are perfect squares. They're not in this list over here. So we have 2 pairs, 4 and 20 and 16 and 5. We want to use the biggest one, so we'll use 16 times 5. Now watch this. Not using anything but the calculator. We have 5 times 16. 16 is a perfect squared number that we want to use. And over here it is. And what number squared is 16? 4 is. So that means the 16 comes out as a 4. And then this 5 remains underneath. Now if you don't believe me, if you want to check your answer, here's all you got to do. Take the square root of 80 and you get that decimal. Now I'm going to take 4 square root of 5 and see if the decimals match up. And they do. So I know I'm correct. And 5 doesn't break down any, so we're absolutely done with this problem. So the little feature in the calculator are the graphing items. knowing how to type it in can actually save you a whole lot of work.